All right, here's our second scenario. All right, so again, we're going to kind of run through it, and I tried to make this one a little bit more complicated than just the two card scenario, just to give you something a little bit more to work with here. So when a football team gets the ball within the 20-yard line, the coach has three play options. He's either going to throw a long pass, he's either going to throw a short pass, or he's going to run the ball. And then that play will result in a touchdown being scored or a touchdown not being scored. All right? And so we're given some general probabilities about some of the situations that can occur here. All right? So we got the probability of throwing a long pass is 15%, throwing a long pass and not scoring a touchdown 12.75%, the probability of getting a touchdown given that they did a short pass play is 12%. The probability of running the ball and scoring a touchdown is 2%. The probability of not scoring a touchdown, given that they ran the ball, 96%. Holy cow. And so what we're going to do first is we're going to take those probabilities and let's start to make the tree diagram. So, team gets the ball within the 20-yard line. Coach had how many options? 3 options. So this is where the tree diagram is going to get a little more fuller, if you will. We've got 3 possibilities. So I'm going to do LP for long pass, I'm going to do SP for short pass, and I'm going to do R for run. Okay? And then if they do a long pass, regardless if they do a long pass, a short pass, or a run, then they said the resulting play either results in a touchdown or not a touchdown. Touchdown complement. And if they run the short pass, they're either going to score a touchdown or they're not going to score a touchdown. And if they run the ball, they're either going to score a touchdown or they're not going to score a touchdown. So in the end, there's how many different possibilities that could happen here? 1, 2, 3, 4, 5, and 6 different possibilities in the end, right? 3 of them involve scoring a touchdown, and 3 of them involve not scoring a touchdown. So now let's figure out where these probabilities belong at. So first off, probability of a long pass, 15%. So long pass, that's this first branch right here. So we can put 15%, 0.15, right there. All right, probability of a long pass and no touchdown. Well, that's 2 things happening back to back. That is a long pass and not scoring a touchdown. All right, so don't be tempted. This is where people will go, oh, that 12.75%, that belongs right there. And I would say, no, 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 no. This is a singular event. This represents not scoring a touchdown, given that they did a long pass play. So where does this 12.75% go? It belongs at the end of this overall branch. So again, this represents the long pass and they did not score a touchdown. That represents this 0.1275. Okay, so if you've got that and in there, that means you are at the very end of a branch. All right, next one. Touchdown given short pass. All right, so let's take that conditional. We know that they threw a short pass, right? That's our given information. So that means we know we're on this path of our tree diagram. So given that they threw a short pass, then the probability that they score a touchdown, right? Because we got 2 possibilities after a short pass. They're either going to get a touchdown or they're not. So keep in mind, this is a singular event here, the probability of a touchdown. The conditional part is just extra information. It doesn't represent also something else that happened. So this touchdown represents this touchdown branch. So this 12% here goes on this branch alone. Okay, so there's a 12% chance of a touchdown given that they threw the short pass. All right, fourth one. Probability that they run and score a touchdown. So again, 2 things happening here. They are running and they're scoring a touchdown. So that again represents this overall final end result. Running and scoring a touchdown, 2%. And then the final probability given to us. No touchdown. So you got to keep in mind, How many situations are there where there's no touchdown? Well, this is a no touchdown, this is a no touchdown, this is a no touchdown. Well, which no touchdown are we talking about? It's the one, given that you ran the ball. Well, let's see. It's not this one. That's when we threw a long pass. It's not this one. That's when we did the short one. It's this no touchdown. So that 96% goes on that branch. Again, this is one event. No touchdown is one singular event. The conditional part is just extra information. All right. So there's what we know so far. And we got a lot of branches and a lot of ends of branches that have probabilities missing from them, right? So guess what we're going to do next? We're going to figure out what all of those other probabilities are. So where on earth do we start? So here's what I would start to look at first, is look at your individual branches, like the clumps together. Like these three probabilities have to add up to be 100%. And right now I only know the 15%. All I know is that this probability and this probability have to add up to be 85%, so that when it adds to this 15%, I will get 100%. But I don't know what those individual probabilities are. So now maybe we go look at these branches. These two branches have to add up to be 100%, but I don't know either one of those branches. These two branches have to add up to be 100%. Ooh, and I know one. This is 12. So that tells me that this branch down here on the no touchdown branch, given that they ran a short play or a short pass, this has got to be the leftover of the 100%, which is going to be 88%. So again, these have to add to be 100. And look, we can do the same thing down here for those final two branches. 96% of the time, they're not going to score a touchdown given that they ran, which means if they don't score a touchdown 96% of the time, then only 4% of the time they're going to score a touchdown given that they ran the ball. All right. So, but what about those? We'll get there. We'll get there. Calm down. Calm down. We'll get there. Now, there's a couple places we could go to next, and that's where I would then go to either I would look at these probabilities and see if I can work them backwards, or, hey, how about we start over here with the long pass? Because that was one probability we knew. Now, what we know is when we take this 15% and when we multiply it by this touchdown probability, that gives us this overall dual event happening here, right? Of throwing a long pass and scoring a touchdown. But the problem is, I don't know what that end result is, and I don't know what that probability is of throwing a touchdown given that I threw a long pass. So I'm kind of stuck right there. But let's look at the next branch. If I threw a long pass 15% of the time, and I don't score a touchdown, here's what I do know, though, is that 12.75% of the overall time, I'm going to throw a long pass and not score a touchdown. So how did that 12.75% come into existence? That's whenever I take this 15% and I multiply it by this something percent, and I know the answer is going to give me 12.75%. All right, so now I just got to use a little bit of algebra in here. So 15% times what gives me 12.75%? Well, let's just use our calculator. Really what we're doing here is we're taking the overall 12.75% and we're dividing it by 15%. And so let's see, 85%. So what this is saying, 85% of the time, the team doesn't score a touchdown, given that they threw a long pass. So getting that 85% really helps me because now I know the percent of the time that they do score a touchdown, given that they threw the long pass. This has got to be the leftover 15%, right? Now, at that point, I can go back and figure out this overall probability. How so? I can take this 15% times this 15% to get that overall probability, which ends up giving me 2.25%. Now, I'm also going to throw this out here. There is another way that we could have gotten that number, and that is this way, that these two probabilities have to add together to be this 15%. How so? Because these two branches overall involve throwing a long pass. And we're either going to score a touchdown or we don't score a touchdown. But regardless, we threw a long pass in both of these situations, right? So these two probabilities must add together to be this 15% overall. So what I could have done to get that 2.25% is I could have just taken this 12.75% and subtracted it from this 15% and gotten this number as well. So just a second possibility to consider there. All right? So let me erase that at least. All right, so let's keep working our way down here. Where can we go to next? Can we deal with this branch next with the short pass? And we're going to strike out because, one, we don't know this, and two, we don't have either of these ending possibilities here. But what we know is that this probability times 12% gives us this final answer that we don't know. Likewise, the short play probability pass, or the short pass probability, times 88% gives us this final answer, and we're stuck. So let's go down to the bottom. And you might go, but we're in the same situation on the bottom. We don't know what the running probability is. And that's true, but we do know this probability. So if we took this running probability and we multiplied it by the 4% chance of scoring a touchdown on that running play, we know overall that that happens 2% of the time that they run and they score a touchdown. So again, a little bit of basic algebra here. What value times 0.04 is going to give us 0.02? Well, isn't 2% half of 4%? So this is going to end up being 50%, or 0.5, 0.50, however you want to express it there. Now, to get this probability, I'm going to use that piece of information I told you up here earlier about the 0.0, I left a 5 off. There we go. Is that these two probabilities must add together to be the overall probability of running the ball. So if 2% of the time they run the ball and score a touchdown, then that means that 48% of the time they're going to run the ball and not score a touchdown. Because again, these have to add up to be all the way back here to get this 50%. Now again, you also could have gotten 48% by taking this 50% times this 96%, and again, that gives you 48%. All right, now we get to go back to that middle, that short pass play. If this is 15% and this is 50%, that's 65% so far, which leaves us with 35% for throwing a short pass. And so now we can finally figure out what these ending probabilities are. So if I had 35%, let's clear this out here. So 35% chance of throwing the short pass times a 12% chance of scoring a touchdown is 4.2%. 4.2. So 0.35 times 0.12 gives us 0.042, right? 0.042? Yeah, okay. I don't know why I was second guessing myself there. Now, to get the other final number, really, again, use this idea that these two have to add up to be that overall 35% in the end. So what's that going to give me? 0.308, I do believe. Or again, you could take this 35% times this 88%, and that will also give you this 30.8%. All right, now that we've got all of those probabilities, all of our singular probabilities, all of our conditional second branch probabilities, and all of these final end branch probabilities, now I've got some general probability questions to answer based on this tree diagram. So we're going to start off a little bit on the easier side, and then we're going to ramp our way up to some more difficult problems. So first off, what is the probability that they did a running play? Well, there's a couple different places where we could get that. The easiest place would just be to go, well, here's a running play, and that was 50% of the time it was a running play. And so is 50% really the final answer? Yeah, it really is. There was nothing that happened before the running play, so this is strictly it's 50%. Now, what you could also do is go over here and look at all of your end branch probabilities and go, I'm looking for the ones that resulted in a running play. So let's see. Is this a running play? No, this was long pass. This was long pass. This was short pass, short pass. Hey, this was a running play, and this was a running play. So I could take these probabilities and add them together, and 2% and 48% give me still my 50%. So these two end branches, in the end, will always add up to be whatever that very beginning branch was that they started from. Likewise, these two probabilities are going to add up to be all the way back here to this 35%, and these two probabilities are going to add up to be this 15%. All right, so in general, what was the final answer here? The final answer was 50% or 0.5 or 1/2, however you want to express it. All right, second problem. What is the probability that they did a long pass and the upside down U, the intersect symbol, long pass, and it did not result in a touchdown, right? Touchdown complement. So that means we are on the long pass branch route here, and then we split. Now we got to know, did they score a touchdown or not score a touchdown? We're saying, and they did not score a touchdown. Now, that is two situations that happen kind of back to back. Right? Long pass, and they did not score a touchdown. That really represents the end branch probability of those two events. So the final answer is this 0.1275 that we already came up with here. Okay? What other way could you have gotten that? Well, just, I guess, multiply 0.15 by 0.85, and that's how we got the 0.1275 to begin with. So again, this was just a back-to-back situation. We already calculated what that probability was. So again, nothing too terrible. Nope, too far. Nope. Where am I at? Where am I at? There we go. Okay, so third one. Touchdown, given that they did a running play. So this one's a little bit different, right? No, forgot I did something. There we go. So they want us to figure out, this is a singular event here, what is the probability that they scored a touchdown? But then I got to think about, well, there's three different ways in which they could score a touchdown. They could score a touchdown 15% of the time. They score a touchdown given that they did a long pass. There's a 12% chance that they'll score a touchdown given that they run a short pass. And there's a 4% of a touchdown given that they ran the ball. And it's this last probability that really represents what we are being asked to find. So touchdown, given that we are on the running path. So we know we should be going along this pathway because that was given to us, right? Given that they did a running play. Then what is the probability that they score a touchdown? Well, it's this. It's this 4% right here. Now, if you wanted to use the formula for conditional probability to get the 4%, then here's how we would have to tackle that. So let me scoot this over here. So using the formula that I shared with you earlier, it's the probability of doing both of these events, getting a touchdown and running, or really we would run the ball first and then score a touchdown, divided by the probability of whatever the conditional part was, which in this case is running. So what's the probability of scoring a touchdown and running the ball? Well, that's this, 0.02. Divided by the probability of running. Well, what was the probability of running in general? Didn't we answer that as like the first question? That was that 50%. So if I had 0.5. So then on my calculator, if I did 0.02 divided by 0.5, that gives me my same exact answer of 0.04. All right, and then there's that 0.04 that we just said, hey, it's right there in the tree diagram. So you could use the formula for conditional probability to get the answer, but again, you didn't necessarily have to use that. All right, fourth problem. What is the probability we do not score a touchdown? So this is a singular probability, but they give us some extra information. Because again, which not touchdown scenario are we talking about? Are we talking about this one? Are we talking about this one? Are we talking about that one? Well, given that they were on the long pass play, well, here's that branch of going along the long pass, so it must be talking about this 85% is that particular probability. And so again, we're done there. But again, I'll show you real quick. If we wanted to use the formula, then it's the probability of both of these events happening back to back divided by the probability of whatever the conditional part is, which in this case is the long pass. Now, the long pass, I know, only happens 15% of the time. And they score a touchdown or they do not score a touchdown, sorry, and it was the result of a long pass. Well, that's this probability. So if I took 0.1275 and divided it by 0.15, you know what I'd get in my calculator? 85%, which is still this same exact number. All right, number 5. What is the probability of scoring a touchdown? Well, here's where it gets a little tricky. All right, because I know inevitably people would do this. They would go, "Oh, great, scoring a touchdown, 15%, 12%, 4%. What do I do with those? Well, I add them together, right? So 31% chance I would score a touchdown." And I would say false. And you'd be like, but I just add those up, right? But these are all conditional probabilities. This 15% scoring a touchdown is given that you knew that they ran a long pass play. And this just says that they just scored a touchdown. So we're not actually going to use any of these specific numbers to get this final answer. All right? And another way that I could help show and kind of prove to you that you just don't add them up would be, what if, okay, a little side what if here, what if I had said, what's the probability of not scoring a touchdown? Would you really add together these 3 probabilities, which are going to be way over 100%? And no, you really wouldn't, right? So that's why you shouldn't add the touchdown probabilities. Now, in this scenario, what I would really recommend doing is looking over here at the end branch probabilities, and then just looking at all of these 6 situations and going, well, which one of these resulted in a touchdown? Well, this one resulted in a touchdown, so I want that one. This one did not result in a touchdown. This one resulted in a touchdown. This one did not. This one resulted in a touchdown. And that one did not. So I just need to add together this, and this probability. And all these probabilities are disjoint or mutually exclusive from each other, so I can freely add them together without any concern about there being like an overlap of an event, because I can't score a touchdown by doing a long pass play and a short pass play and a running play. Those are all exclusive from each other. So 0.042 plus 0.02. So in the end, there is a 8.45% chance of scoring a touchdown. So 0.0845. Which now also means you could tell me what the probability of not scoring a touchdown is, right? Because you would just take 1 minus this probability. Because you're either going to score a touchdown or you're not going to score a touchdown. There's only 2 possibilities. All right, what are we on, like 6 or something? I don't know. So what is the probability of a running play given that they scored a touchdown? Now this is a little different. Because previously we did a problem that was like this, right? And I said, all right, touchdown, well, that's these probabilities, these green ones, but I know that they ran the ball, so it had to be that 0.04, right? But this probability question is different because they're asking me to find the probability of what happens first given what happens next. And that's not usually the order that you would do events in, right? Now, if I said, what's the probability of a later event given that a first event has happened, that makes more logical, chronological sense here. But this is kind of like asking me to look ahead into the future and know what happened, to know if I ran, or what's the probability of doing a running play there. So this one we're not just going to be able to easily grab out of our tree diagram. So this is where I would recommend more using the formula. So the probability of both of these events, running the ball and scoring a touchdown, divided by the probability of whatever the conditional part was, which is just scoring a touchdown. Now, we've actually figured out both of these before, right? Like running a touchdown, or running the ball and scoring a touchdown. That's this 0.02 that's right here. And then divided by the probability of running or scoring a touchdown, which we just figured out, right? Was 0.0845. So out of all 0.0845 of the times that we score a touchdown, 2% of those was the result of running the ball. So now if I divide these, 2% divided by 8.45%, whoa, what on earth happened there? Let's try that again. 0.02 divided by 0.0845. I think I'm not seeing my decimals. There we go. Okay, I knew something wasn't right there. So this comes out to be approximately 0.2, and then I didn't see what my numbers were. 2367 going to 4 sig figs. 0.2367. 0.23, that's a 3, I promise. So a little less than 24% of the time, they ran the ball knowing that we were going to score a touchdown. All right, the seventh problem, I think we're just going to call it seventh. What is the probability that they do a long pass play, union, and this is where we use the word or they do a short pass play? Well, what did we do in cases of or with probability? Well, we got to add, right? We got to use just the general addition rule. So a long pass or a short pass, well, there's a 15% chance that I do a long pass, and there's a 35% chance that I do a short pass. So do I really just add these two probabilities together to get 50%? 1/2? And yeah, we can do that. Now, keep in mind, a long pass and a short pass, those are disjoint or mutually exclusive events. So there's no overlap. There's no commonality between them. So sure, you can just add them together. Now, the other thing you could have done is you could have looked over here at your end probabilities and just went, all right, which ones of these probabilities are all about either doing a long pass or doing a short pass? And you would go, hey, long pass, keep it. Long pass, keep it. Short pass, keep it. Short pass, keep it. Neither long nor short, neither long nor short, don't keep these. And so if you add up all of these probabilities, what are you going to get? You're going to get 50%. So there's a second way that you could have gotten the final answer there. All right, last one, and then I'm going to leave 2 for you all to try out. So what is the probability that we run the ball or union we score a touchdown? Now, this one, not going to be the same way here. If you think about it, can you do both of these things? Can you run the ball and score a touchdown? Yeah, we can, right? So these are not disjoint or mutually exclusive events. There is some overlap in here. Now, what I would honestly do in this scenario is, again, I would just look at these end probabilities. And I'm looking for either running or scoring a touchdown. And if I happen to see both, bonus, that's icing on the cake, right? So this first one, does this represent either running the ball or scoring a touchdown? Yeah, scored a touchdown. I want to keep that probability. What about the second one? Running or scoring a touchdown? And no, it's neither one of those. So I don't want that probability. Next one, hey, at least I'm scoring a touchdown. Cool, keep that one. Short pass, not scoring a touchdown, doesn't meet either of my criteria. Running and scoring a touchdown, hey, both of them, we're going to keep them. And then the last one, hey, at least I'm running, right? I didn't score a touchdown, but hey, at least I'm doing the running play here. So I do want that one. So I want this probability, that probability, this one, and this one. And all of these end branch probabilities are naturally disjoint events from each other. You cannot do any two of these events at the same time. So at this point, you are free to add together all of those probabilities up. So I already know what these two add up to be. That's 50%. And let's see, what do these add up to be? That's 0.0645, right? Yeah. And so add that to my 50%, and this ends up giving me, what, 56.45%. 56, I swear that's a 5, not a 6. All right, so there's the probability that I run the ball or I score a touchdown. And yes, that also includes the possibility of doing both of those things. But in cases of or in probability, that leaves open the possibility that both events could simultaneously occur. All right, so the last two problems here. I'm going to let you all tackle these two, and we will discuss these the next time in class. So good luck.